We're going to start trigonometry this month with this first section that gives the basics of it. You should recognize some of it because you did get the beginning of this in Integrated 2, but we're going to go beyond that right now. And then when we come back next month, we're going to go a lot deeper and do the rest of it. And I think we'll end up going, that's month 8, and we might go a little bit into month 9 doing some of this as well. But I'm not sure how much we'll need. Already I know 11.2 is going to go to next month. For those who came in later, I've decided, because there's so much in here, in fact, I may be able to get like 8 test questions out of this one section. I'm going to take section 11.2 and make it part of next month. So if you did line 11 on the cover sheet, just keep that work and hold on to it and review it when we get to next month. But if you didn't get to it, you can wait till next month to do it. But we are going to do a lot in 11.1 because there are a number of different things in it. Okay, first one, the basic trig functions are sine, cosine, and tangent. And one of the ways to remember it is this little ditty, so katoa. And so, S-O-H, is remembering that the sine is the opposite over the hypotenuse. So if this is the angle we're looking at, the opposite for that is this one. And you divide that by the hypotenuse. So whatever amount is here, you divide it by that. So let's say I said that this was the amount 4, and that, oh no, I'm going to make this one 3. Because I'm realizing this one's a shorter side. Let's make this 3 and let's make this 5. Okay? Because this is a Pythagorean triple, they call it, when the numbers are all integers like that. So the sine is the opposite over the hypotenuse. So the opposite, 3, and the hypotenuse, 5. 3 over 5. So SOH is one way to remember that. The cosine, if you remember ka, so ka toa, and then CAH, it's the adjacent side amount divided by the hypotenuse. And if this is the angle, this line is the one that's adjacent to the angle, to that angle. And I'm going to say that that adjacent is the amount 4. Okay? So that means that the cosine would be 4 over 5. And the tangent doesn't use the hypotenuse at all. For the tangent of this angle, it's the opposite divided by the adjacent. So it's going to be 3 divided by 4. These can be made into decimals as well. So if you said 0.6 or 0.8 or 0.75, that would be considered correct too. Okay. So what we start with here is the 3 other trig functions that go with them. Cosecant, secant, and cotangent. These are actually nothing more than simply the reciprocal of the other ones. The problem for most people, and for me, which I have to force myself all the time to think about it, is that cosecant sounds like it should be going along with the cosine, because they both say co, but they aren't. The cosecant is the reciprocal of the sine. So that means where the sine is the opposite of the hypotenuse, the cosecant is just the opposite of that. So what I'm going to do here, when I look at this one, notice I also switched it because you need to get used to triangles not always being one certain way. You need to recognize if this is the right angle, that means this is the hypotenuse. And since this is the angle we're looking at, the opposite is this one over here. And the adjacent is the one that's next to it. I'm going to use the same numbers. Let's say that the opposite, that this length is 3, this length is 4, this length is 5. For the cosecant, I can remember hypotenuse over opposite, or I can just go to the sine and switch it and make it 5 over 3. For the secant, you have to memorize that the reciprocal of the cosine. So I'm going to go to the cosine and just flip it and make it 5 over 4. And the cotangent is the opposite of the tangent. So when the tangent of this was 3 over 4, that means it's going to be 4 over 3. Just simply switching. And that's how you do cosecant, secant, and cotangent. They don't look that different now as the reciprocal. And when you graph these, the tangent, the cotangent graphs as the opposite of the tangent. The other two are weird. You, instead of getting, when you graph it, you'll see the cosine and sine are like sound waves. In fact, the sine curve is a sound wave. If you study anything deeper into in physics and science, in sound, they're graphed as a sine function. Well, for sine and cosine, their reciprocals are parabolas that are at the top or the bottom of it. It's an interesting little thing. And you can do these on the graphing calculator. So we'll do those when we get to the graphing sections later on. That would be part of next month. Okay, let's look at page 2. I am going to give you a following. We're going to go through one here. Let's say I am going to tell you that for this triangle, the hypotenuse, actually I won't tell you the hypotenuse yet. I'm going to tell you that the small side has an amount of 6 units and the longer side has an amount of 14 units. By giving you that, you can now find all of these. For all of these except for tangent and cotangent, you need the hypotenuse. Because it's a right angle, with just any two of the three, you can figure it out with the Pythagorean theorem. So the first thing we're going to do is a squared plus b squared equals c squared, because we need to know what the hypotenuse is. So that's going to be 6 squared plus 14 squared is equal to c squared. That's 36 plus 196 equals c squared. 232, and when you take the square root of that, c is equal to plus or minus the square root of 232. Now, when you get up to that, I've got 2 points of two things about this. First one is, it's always plus or minus when the square root of a number. But we're talking about an actual distance. Distances can't be negative. Therefore, the negative part of this, we can just ignore that. Okay? If it wasn't a distance and we were just getting an answer, then yes, you'd have to use both answers. But here, it's a real, actual thing that we're measuring, so get rid of the negative. Second thing is, if I tell you to give me exact answers, if I say give me exact answers, then you can't make that a decimal. If I don't say exact answers, then you can make it a decimal. So if I did the square root of 232, it would be 15 something. 15 something, I guess. I guess I'll do that just to see. How much?
15.23.
15 point what?
23.
23. Thank you. Thinking of rounding that down, but that would be too much. Let's make it 15.2. Okay. So I'm going to say approximately 15.2. So I could use then that as 15.2 for all hypotenuse, except that if I say exact answers, that's not exact. Therefore, I'd have to leave it as a square root. So in this case, I'm going to say exact and work on this because I want to remind you about rationalizing when you have to do that. If I don't say it, then you can use decimals all you want. So watch for the directions and see whether I say use an exact answer or if I don't say anything at all. If I said something like round to the tenths place, that's like implicitly saying, yes, you can use decimals because if you're not using decimals, there's no reason to do any rounding. So that implicitly tells you to go ahead and round it, to use decimals. So here, though, I have square root of 232. Remember something like the square root of 8 is not an acceptable answer because there's a perfect square in it you got to pull out. So you've got to pull one out of here. This is actually 4 times 58, so it's actually 2 square root of 58. So I'm going to put 2 square root of 58 here. Now that I have those three, let's do these. SOHCAHTOA, S-O-H, so this is opposite over hypotenuse. Sine SOH tells me I'm doing the opposite number over the hypotenuse. 6 over 2 root 58. Little problem here is that I can't leave 2 and 6 because I can reduce it. In fact, there's 2 problems here. One is I have to simplify this. 2 goes into 6 3 times. Let's fix that one right now. The second thing is you can never leave a square root on the bottom of a fraction. But the way to take care of that is to multiply by that square root. If I multiply by 1, and use the square root, so this is the method called rationalizing a fraction. Now I get 3 root 58 up here, and just the number 58 here, because square root of 58 squared, and the square root goes away. So this is the sign. For the cosine, that one is CAH, ka. Cosine is the adjacent over the hypotenuse. So that's going to be 14 over 2 root 58. 2 goes into 14 7 times. And I'll multiply again by the square root of 58. It gets tedious after a while. It gets tedious pretty fast, actually, but you got to do it if it's an exact answer. So we get 7 root 58 over the 58. That's why whenever I don't tell you exact answer, you really appreciate it because you don't have to worry about the square root parts. For the tangent, I'm going to bring that over here because I'm running out of room here. The tangent is going to be the, remember TOA? It's the opposite over the adjacent. The opposite is 6 over the adjacent 14. And when I reduce that, that's 3 over 7. Okay. For these other 3, just take the reciprocals. The easy one right now is this, 7 over 3. Remember, the cotangent is the tangent's reciprocal, so just do the reciprocal. For these other ones, now let's look at this. If I were to take this one and do the reciprocal, I have 58 over 3 root 58, and I got to do this rationalizing again. I'm going to tell you right now a trick to these is when you're having to do rationalizing, go back to where before you started the rationalizing and flip it right there. Then you don't have to worry about any rationalizing. Since the cosecant is the reciprocal of the sine, just take any one of the levels of it and just do it there. And if you do it here, you save yourself the trouble of having to do more rationalizing. So we get square root of 58 over 3. For the secant, that's the reciprocal of the cosine, so I come back here to before I had to rationalize it, and I'm just going to do the reciprocal. Square root of 58 over 7. Now, if I was doing this one at 15.2, if I was doing it with 15.2, I would have done 6 divided by 15.2 up here. 6 divided by 15.2, and I get 0.3947, or that's so close to, that could be 0.39, that's so close to 0.4 that I'd call that 0.4. If you multiply that out, you'll get 0.4. Okay, so 0.4, I'm going to say approximately 0.4, so that's what the sign is. So if you don't have to do exact answers, then just do 6 over 15.2 and get 0.4 and put that for your answer. So be very happy when I don't tell you one way or the other. Okay. On the bottom one, this is one that you can practice if you want to, but I'm going to not have time to do it, so I'll leave it for you. And I will say that this is 3. The larger side is 5, and I'm not going to tell you this one, so you can figure that out. And I don't say here to do exact answers, so you can practice it, since this will be a square root. You can practice like this if you want to, and or you can go straight to doing it with decimals and do it as a decimal one. But that one, I will put the correct answers for this one up on in Google Classroom when I post all this tomorrow. But what you see from these first 2 pages is SOHCAHTOA TOA helps you remember opposite over adjacent or hypotenuse or whatever it is. The reciprocals for the cosecant and secant and cotangent. And then when you use them, if you need to, you'll have to do rationalizing. If you don't have to, use a decimal, but you might have to get all 6 of them. Okay, let's look at page 3. Here's one of the types of applications of these. You're looking at a building that's 70 feet high, and the angle you're looking from is 64 degrees. How far away are you from it? Okay. Now, these only use sine, cosine, and tangent, so they're similar to what you've seen before. It was part of last year when we did those first. but it's worth reviewing. You see things like this usually on the things like the SATs and the various other state tests too. So you don't have to like draw anything out. I find for almost all the word problems in math, if I do some kind of sketch of what it's telling me, it helps me make sense of it more. It's one of the techniques you can use to help yourself out. I highly recommend you do it. It doesn't say here you have to do it. That doesn't mean you can't do it. So I'm going to make a little building. Now, admittedly, sketching is being a little too nice to me about what I'm drawing, but I'm going to try to do. Here's the entrance. Here's a couple of windows. Okay, there, that's enough building. So this building is 70 feet high. I'm standing out here somewhere looking at it, and the angle, okay, I can't quite draw the angle right, but the angle is 64 degrees, and if I'm standing right here, well, I can sort of do stick figures, okay. I want to know how much this is. So part of the idea here is, if you know a couple of parts of a triangle, put a variable and make an equation. So writing an equation to solve is one of the skills you need to have. In fact, sometimes the way the questions are worded is, write an equation that will help you solve this and then solve it. So what I'm looking at is if I'm here, I know this angle, I know the thing that is opposite. Now, the opposite one is used in sine, or opposite over hypotenuse, and it's used in tangent, opposite over adjacent. So I'm probably going to use either a sine or a tangent function for this. The hypotenuse I don't really need. The question doesn't ask me how high is it from, or what's the distance from where I'm standing to the top of the building. If it said that, I'd have to find the hypotenuse. All it says is how far is it for me from here to the building, which would mean the logical sense would be the shortest distance, which would be here. So that means I need this, which is the adjacent. So I know the opposite. I need to find out the adjacent. And so cot TOA, T-O-A, the tangent is the opposite over the adjacent. So that tells me that I can say that the tangent, and I'll just write it as T-A-N, the tangent of 64 degrees is equal to the opposite, 70, over the adjacent x, and I now have written an equation. That's writing a trigonometric equation. Because now we will be able to figure out what this is. Whenever you have an equation and you only have one missing thing in it, you can move the rest of the stuff around and figure out that one missing thing. So this x is the distance, the walking distance to the building. Well, thing you have to watch out for, and what I see here, I'll tell you right now, this is one of the types of questions you'll see on the test. Okay? I've got enough others that I don't mind telling you. You'll see one really just like this, and you're going to end up with a variable. If you do it right, you'll have a variable on the bottom of the fraction. Pay attention to what you've been doing since about 5th grade, where you move things around an equation. For some reason, as soon as there's a word in it like that, some people just let all the stuff they've learned before just go out of their brain, and they forget that if you have this on the bottom and you don't want it there, you can multiply both sides by that. So I can cancel out the x, and I get x times the tangent of 64 degrees is equal to 70. I have seen everything. I have seen this one divided by x. I've seen the x brought up here and made 70x for no reason at all. I've seen the x just disappear. I don't know what people are thinking sometimes, but they're not following the things that they've done for years. And all of a sudden they see this and it's like it goes out of their brain. So I'm warning you right now, remember what you can do. I can get rid of the fraction by multiplying by the denominator and do it on both sides. But I want the x by itself. Well, now I have x times something. This is just a single thing. This is like 4. If this was x times 4, you just divide by 4 because you know you can do that. Okay, so let's just do that. Except it's not 4, it's tangent of 64 degrees. That cancels out. So x is equal to 70 over tangent of 64 degrees. This is actually probably the most common thing that I see wrong, where people do this and then they don't divide. It's like, this is x times that. All they do is they pick up tan 64 and they bring it over and plop it next to the 70 or whatever number's on the test, and they do 70 times that tangent of 64. Wait a minute. You can't just take a multiply and just bring it to the other side. You've got to divide to get rid of it. So you just put that in the calculator. 70 over tangent of 64. 70 divided by put in tangent, put in 64. You don't even have to put the last parentheses because there's no other competing ones. And it'll tell you it's 34.14. Well, we're talking feet here. 31.1 feet. That's so close to 34, we can just say approximately 34 feet. So the distance between where you're standing and the building is 34 feet, just about 34 feet. So remember what you do is you set up something. You don't have to do this if you recognize what to do, but you see how it really helped me to determine opposites and adjacents. So it really is worth it to do some kind of little sketch so you are aware of what to do with it. The one on the bottom is the exact same type of problem. I'm going to let you do that one yourself for practice. You can if you want to. I'll just tell you it's the same exact thing. I'd recommend to set up a building or a line and do 80 feet and do the angle, and then it's set up the same way. Now let's take a look at page 4. Okay, another part in this section is these special triangles where there's like an automatic relationship. 30, 60, 90 triangles and 45, 45, 90 triangles. The relationship between the sides is the same every single time. So I'm going to do, let's say, I guess I'll start with this one. The relationship here, if you have a 30, 60, 90, take this one and call it the amount 1. Now, it might be a different amount, but the relationship would be the same. Whatever amount this is, the hypotenuse is immediately doubling, automatically doubling, every single time. If it's a 30, 60, 90 triangle, the small side is half of the hypotenuse, or the hypotenuse is double the small side, automatically every time. The long side is whatever this amount is times the square root of 3. So if this was a 5 instead of a 1, this would automatically be 10, and this would automatically be 5 times root 3. In fact, what I'll do is I'll put 1 times root 3. So whatever this is, times root 3 gives you that one. And this one is just double it automatically, every single time. So just memorize those little things. You will need to have that memorized because one of the things we'll do next month is the unit circle, where you look at the sine and cosine for all the angles around the unit circle, all the main angles around this unit circle. 30 and 60 are 2 of those angles, and 45 is the other one. And then they repeat 3 times. So you need to know the sine, cosine, and tangent for those. So let's figure them out. Now, one of the things here is I need to write it for 30 degrees. And what I forgot to do was to put a line here and do 60 degrees. So I'm going to ask you to put 60 degrees there and write sine. And I guess what I should do is put sine of 60 equals, cosine of 60 equals, tangent of 60 equals, and theta this time for all of these is going to be 30. So let's start with the 30. SOHCAHTOA. SOHCAHTOA. So, oops, that's an O there. So for the sine, I need the opposite over the hypotenuse. Opposite is 1, and the hypotenuse is 2. It's 1/2. The cosine is the adjacent. Cosine is 30, is the adjacent, which is square root of 3 over 2, over the hypotenuse. The tangent is the opposite over the adjacent, 1 over square root of 3. Well, that means we need to rationalize it. If you multiply top and bottom by the square root of 3, you get square root of 3 over 3. So that would be the tangent. Okay, now we're going to do the 60 degrees. You're going to see an interesting thing. So let's now look at 60 degrees. I'll put double arc there because it's different from the 30. Now for this one, these changed. I mean, these don't change, but now when you ask for the sine and you're looking at the opposite is now this number. For 30 degrees, the opposite was 1. For 60 degrees, the opposite's over here. So it's the square root of 3 over 2. So the square root of 3 over 2. For the cosine, that's the adjacent over the hypotenuse. And for 60 degrees, the adjacent is the 1 over the hypotenuse. It's 1/2. Notice this. Because they're opposite angles on the same right triangle, the sine and the cosine are opposites of each other. So if you remember that, that's one way to sometimes easily get each other, or you could just focus on SOHCAHTOA to get it too. The tangent of 60 degrees is going to be the opposite, square root of 3 over 1, the adjacent. So that's square root of 3 over 1, which is square root of 3. That is simply the reciprocal of the other tangent. So whereas these are crossing opposites of each other, in the tangents, they're actually reciprocals of each other. So that's another thing that might help for thinking about it. So you should know those. In many places, they make everyone memorize that the cosine of 60 degrees is 1/2. Rather than my making you memorize it, of that, I'd like you to memorize these so that you can get these when you need to, as opposed to remember bunch 6 of them. All you have to remember is 3 of them, and just remember the relationship, and then you can get them when you need to, using SOHCAHTOA. Okay, let's look at the bottom. The relationship here is a little bit easier. First thing is, for two 45-degree angles, this length and this length have to be the same, because if that angle is the same and that angle is the same, it's an isosceles triangle. That means the two lengths have to be the same. So we're going to call that a 1, and we're going to call that a 1, because there's a relationship for these to this. The hypotenuse is always whatever one of the sides is times the square root of 2. So if this was 3, that would be 3 square root of 2. In this case, I'm using 1, so it's 1 square root of 2. The sine of this, it doesn't matter which one I take. The sine is going to be the opposite over the hypotenuse, 1 over square root of 2, which means I've now got to rationalize it. So that's the sine. The cosine is the adjacent over it. It's the same thing. So I don't even have to rationalize it. I just write square root of 2 over 2. It's the same 1 over square root of 2. So the sine and the cosine are exactly the same. The tangent is the opposite over the adjacent. And 1 over 1, at least everything I've seen, is always 1. That's a nice easy one. 1 over 1 is 1. So now we have those. This one's really a pretty easy one. Really, your main job on this is just to remember those relationships. That these are the same, and then this one's square root of 2 times that. So if this had been 5, that would have been 5 square root of 2, and when you did it here, the 5s would have canceled out. Because whenever you do these, it always breaks down to these. Always comes down to this. Okay, let's take a look now. In 3, all I have here is just to give you some practice ones. And I meant to put some numbers, so actually let's, no, this is not practice. These are to find the angle on these. I know I've got a problem to practice it. Oh, I'm missing one, okay. So here, we don't know what the angle is. And all the other ones, we had an angle to work with. What I'm going to do here is I'm going to tell you that this amount adjacent to it is 15, and and I'm going to say the hypotenuse here is 19. Okay, that'll be enough for this. Not what I had been working on, but I'm doing differently than what I did before. So I want to know what this is. So what you want to stop and think about is the information that you have here. If I want to know, well, forget what that is, just the fact that for this angle, this number 15 is the adjacent. And this number 19 across from the 90 degrees, this is your hypotenuse. So I have the adjacent and I have the hypotenuse. And when you do SOHCAHTOA, the adjacent and the hypotenuse are in the cosine. So I can say that the cosine of this angle is equal to 15 over 19. So if that's 15 over 19, I can do now, and this is where you've got, if you have your graphing calculator, pull it out. If you don't, just watch what I do and make sure you practice it at home. You don't even have to have the graphing calculator. I think you can do this with a scientific calculator, but I use this so much. Yes, you can. You can do it with a scientific calculator. Because on this, it has the sine, cosine, and the tangent. But notice the second function keys are sine minus 1, cosine minus 1, and tangent minus 1. And we have the same thing here on the graphing calculator. Sine minus 1, cosine minus 1, and tangent minus 1. Those are the keys that help you get an angle. So what those tell you is that cosine minus 1 of this will tell you what the angle amount is. So those keys basically work backwards. If you know what the cosine amount is, you can use that to go back and figure out what the angle is by using that key. So I'll do it with this one. Okay, answer. I'm going to do cosine minus 1, 15 divided by 19. And it gives me an angle of 37.863. Watch out when these problems come up, because I might say round to the nearest integer, I might say round to the nearest tenth. Watch whatever it is. Here I'm going to round to the nearest tenth just because I feel like it. So it's approximately 37.9 degrees. Or not cosine. Theta is approximately 37.9 degrees. Okay. I'm going to give you a couple others here that you can use for practice. I'm going to tell you that this one is 12 and this one is 8. Okay, I'm going to tell you that for this one you have 25, and this one you have, let's say 18. Okay, so figure out those using -1, whether it be tangent, cosine, sine. You don't know yet until you think about, compared to these angles, are you given the adjacent, are you given the opposite, are you given the hypotenuse? Use that to help you with determining them. So those I will give you, I will tell you on, I'll post that on Google Classroom. One more thing to do, turn to this last page that I gave you, which is page 6. Elevation and depression. That simply means based upon the way that the angle is set up. So let me show it this way. This example I think will help show it. The angle of depression of the sun is 40, oops, I should have put 40 degrees there. The shadow of a building is 30 feet long. Well, I'm going to make my building again. And what this is saying, that if the sun was up here and it's shining like this, there is a line like this, and this is the shadow. So the sun's here, so all of this is in shadow right now. The building is giving you a shadow here. That's 30 feet long. The angle of depression is the angle going down. If it was angle of elevation, we would have the angle that's going up from the bottom. But when it's angle of depression, think of it as going down like that. So whenever you see that, you know you're working at the top of a triangle when you draw these out. So angle of depression means that this is 40 degrees. And you're supposed to find out how tall the building is. That's going to be x. Once you figure this part out, it's just like the last few pages of problems that you did. We want to find that angle. We know the opposite amount. We know the adjacent amount. Opposite and adjacent sounds like the tangent. So you do the tangent of 40 equals 30 over x, and now you could solve it just like some of the other problems you did. But for these two problems and this top part of 11.1, you have to recognize that the angle of depression means using that angle up there. Angle of elevation would be the one down here. The one on the bottom, you can figure out that number yourself. I'll post it tomorrow. The one on the bottom is the same kind of thing, and I want you to figure that one out as well for yourself. You can do that. You don't have to, but you can. And I didn't get to 11.2. That just confirms that we won't have 11.2 for this month. If you did some of it, you can just leave it and keep it till next month. But we will go through 11.1 on the test.